Alrighty, this lecture should have been recorded on Wednesday, August 30. However, the camera software failed that day or was not installed. So I'm going to re-record the lecture for the benefit of the people who could not attend the in-class presentation, which I do not expect anybody to do because you signed up for an online course. So we already took a peek at Chapter 6. It should have been entirely review since you took beginning Java here, hopefully, and should all be familiar. If not, read it very carefully, regardless of where you took, Java here or another school. You need to have already understood Chapter 6, so it was pretty much a review. Chapter 7 should also be a review, as far as I know, all of the beginning Java classes at Rose go up through Chapter 7. So we're just going to spend a day or two on it. Let's go ahead and do this lecture, and then after we do this, I'll look and see if there's anything else we need to cover. Most likely there won't be. But you do need to read it carefully, especially if you didn't get it all. It's probably towards the end of last semester. Read it very, very carefully and understand it, please. So what we're going to do is we're going to learn about references. We're going to talk about overloaded methods. We already have the idea of constructors, I believe. Maybe a brief mention of overloaded constructors and testing objects for equality. So let's get to it. So to do this, we're going to need a simple class, a car class or something like that. I believe they have a car class example in a chapter as well, but we're going to do a little bit different. So the code won't be the same, but the ideas are going to be the same. So I'm going to make a new project, and then I'm going to create a simple car class. So Java application, next, finish. And then over in the projects, not in the main class, but in its own file, in its own class. So I'm going to go to projects. We'll see our current one here. I'm going to right click on the same package, do new Java class. I'm going to call it car. And the car is going to only have two methods. It's going to have a brand and a color. No. Let's do a color and a number of wheels. Kind of silly, but that's okay. So let's declare a couple of variables. Private int wheels. It can just be, an int. We don't need 3.4 wheels on it. And private string color. So here we go. What we really need to do is encapsulate those. So recall, we always add getters and setters. I'm going to trust you know how to do that. If you're using NetBeans, you can kind of cheat and let it add them, but I really want you to know how to do them as well. So I'm going to type them in pretty quickly. And what I mean by cheating is you can highlight those guys, go to refactor, and encapsulate. But you got to be able to do it by hand as well. You won't always be using NetBeans. You may not have it available on an exam, whatever. So we need two getters and two setters. Void, set color, and it's a string, right? So it has to take a color, has to take a string. This dot color equals the color parameter that's passed in as an argument. Getting an error here. Not sure why yet. Take a look. Semicolon expected. Yeah. See, if I try to squeeze it all in one line like that, that's really a bad idea. I was just going to do that because screen real estate is limited. That's what it should look like. I'm going to come back and make these single line, methods after we type them in. Set wheels. Wheels is an int, so the setter, the so-called mutator, needs to be an int as well. So this dot wheels is equal to the wheels that's passed in as a parameter. We need getters as well. Color's a string, so the getter has to be a string. String color. Nope, string get color. It doesn't take any arguments. So all it needs to do is return this dot color. And similarly, wheels is an int, so the getter, the accessor, needs to be an int, get wheels. It doesn't take any arguments, no parameters. All we need to do is return this dot wheels. All right, we're done with that. I'm going to compile it just to make sure I haven't introduced any egregious errors so far. So I'm going to go up to run, build project, or I'm just going to click the hammer with the broom, or whatever. It looks like I'm seeing some problems here, maybe. I'm not sure what's going on there. Cannot access this file because it is being used by another. Alright, maybe I have another project open. I'm going to close everything. Or maybe two builds were already going on at one time. That's most likely what it was. So once I close everything, all my errors should go away. Alright, I had way too many Java files open. Alright, there we go. I can go back to car, rebuild it all again. The .jar file is not occupied because I didn't have two simultaneous builds going on. Alrighty, so I want to get these down to single lines just because, like I said, it saves screen real estate. That way you can see more of my code on the screen at the same time. But really, once you get these guys, you don't need to see them anymore, right? I could put them down underneath the code that I'm going to add and everything will be okay. So here's what's important. Here's what we're really building up to. You already know how to do that. We need to talk about references. So over here in my main method, I'm going to create a car. Car Chevy is equal to new car. I'm going to set its, what did I call it, Chevy? I'm just, good enough, I'm going to leave it at. So Chevy dot set wheels. Our good old Chevy has 4 wheels. And it's a white car, whatever it is. Now we're going to create a new reference. Typically, or you may, I do at least, is once I do this, I call this the object. Chevy is my object. But it's not really. It's a reference to an object. The object got created out on the heap somewhere, and then this is pointing to it. It's referring to it. So if I do this, car2, and I don't create a new car. Instead, I set it equal to Chevy. Right? You may think, or I would have thought one time, that this copies this object into car2. It does not. Instead, we have 2 references to the same car object. It's just like having 2 street signs that point to the same street. It's the same street, we just have 2 signs for it. It's the same car object, we just have 2 references pointing to it. Which means that if we change the color via one of these references, it's going to be changed for both of them because it's the same car, same object. So if I do this, car2 dot set color to red, we may think that that's giving us a red car and that we still have a white car lurking somewhere, but we don't. If I print out the value of the Chevy color, Chevy.getColor, and remember, you can always pause my stuff in order to catch up with my typing. There we go. I'm going to run it. Is the Chevy's color going to be white as I set it up here, or is it going to be red? And the answer is it's going to be red. The reason it's red is because both of these are references to the same object, right? So we change it via this reference. This reference is still pointing to the same object. All right, I hope that makes sense. So now we need to talk about object equality. I think we pretty much have proven the point here with our Chevy. But we could check to see if Chevy and car 2 are the same. We could just do something like this. Boolean the same is equal to Chevy equal car 2, right? That variable will be true if those two cars are the same. But we need to talk about what it means for those two things to be the same. What Java does is it doesn't compare the contents, it just compares the address that the objects are referring to, that the variables are referring to. So absolutely these two things are going to be the same because it's the same memory address. So either way, if you thought that it was checking the members to see that if you had a red Chevy and a red thing with 4 wheels or whatever, that would make them the same? No, what makes them the same is that they're at the same address. So let's prove that. We're just going to system.out.println Chevy equal car 2 plus that variable, the same. So now when we run them, in fact, we will see that they are the same. That is not a surprise. Is Chevy equal to car 2? Yes, they are. We set them equal right there. And it doesn't matter if we monkey around with the members since they're both pointing to the same address. Chevy and car 2 will always be the same according to equal, or any other metric. Let's create a new car. We're going to create a Ford. So car Ford equals new car. And we're going to do Ford dot set color. What colors are, he's going to be green. And Ford dot set wheels. Not surprisingly, it also has 4 wheels. Now we're going to check to see if our red Chevy is the same as the green Ford. And of course they're not going to be. But we can repeat that experiment. The same is equal to Chevy equals Ford. We will check that out and let's print it out. System.out.println Chevy equal to Ford question mark plus our Boolean variable, the same. Let's see how that works. We're totally expecting it to be false. There's no way that could be true because they're pointing to new objects. Ford is a new car. The Chevy was also a new car. They're completely different references to completely different objects. Let's go for it. And there they are. Of course it was false. But what if we made them the same color? What if all of the members of both objects were the same? We have a red Chevy. We're going to make ourselves a red Ford. You might think that means that they are equivalent. And it's true. All the members, all 2 of them, of both objects now have the same values, 4 wheels and color red. Let's run it again. Let's see if it's going to say that they are true. No, they are still not equivalent. A Chevy and the Ford objects, even though they have the same member values, red 4-wheel car, it's not comparing to true. What if we wanted that to be our metric? What if we wanted the objects to say that they're equal to each other if the colors are the same and the number of wheels are the same? Which is totally reasonable behavior. We want to check to see if our member variables are the same. Just like if you had 2 rectangles with a height and a width, and you try to compare those 2 rectangles. If they both had the same height, they both had the same width, you would want equal to say that they're true, that they compare. So what we're going to have to do to get this to work, to get our red Chevy and our red Ford to say that they are equivalent, is we're going to have to add a dot equals method. So we have to go back to our car. Here's our car class. We are going to override the dot equals method. Every object has a dot equals method, but by default all it does is compare addresses. And we've seen what happens when we compare address. The only time it returns true is if you happen to have two references to the same object. So here we go. Needs to be public. It's going to be a Boolean because it's going to return true or not. True or false equals, and we're going to compare it to another object. Object, I'm just going to call it other. Okay, so why is it an object? Don't we want to compare it to another car? Yes, we do. But the equals method that we override has object defined as its parameter. It's of type object. So the first thing we have to do is to cast that to be of type car. So I'm just going to call this other. I already used, huh? So how about other car is equal to, and we're going to cast it to be of our desired type. We're in the car class, we're going to cast it to be a car. This takes its reference to a generic object and tells the program that we're going to actually treat that object as though it were a car, which hopefully it is. You know, we're comparing two cars to each other, so about the only thing we should ever be passing to dot equals is another car. If we pass in something else that is not compatible with the car class, which is not either derived from it, you know, or the car class itself, then that would blow up as an error. We get an exception. Okay, so we have two cars. We have this car and we have the other car. We need to check to see if they're the same thing. What I'm going to do, and this is a little bit different than how the book shows it, is I'm just going to have a series of if statements. Change my mind on how I'm going to do that. Book shows sticking them all in one statement. I'm going to have several. So if this car's wheels equals the other car's wheels, instead I'm going to make that not equals, because if they're not equals, that's the problem, right? So if the wheels of this car do not match the wheels of the other car, then we're going to return false. Similarly, let's check the colors. If this car's color is not equal to the color of other car, again, we're going to return false. If all of our checks, you know, and we may have 10 or 15 members that we need to compare. If all of our checks are okay, if we never found any differences, then we can return true. And that is a bit different than it shows in a PowerPoint. I'm not sure why we're getting a warning here. We are comparing strings using equal equal. That is absolutely the wrong thing to do. You cannot compare strings with equal equal. You have to use dot equals, just like the method that we're creating here, for all the same reasons. Equal equal only compares to see if two strings are pointing to the same memory address. They're likely not. So we're going to do if this color dot equals other car's dot color. But instead we need to check to see if it's false, right? That messed up as I was typing it. Excuse me. I'm going to retype it. Give you a moment to look at it. Okay, so if this color equals the other car's color, and all that's equal to false because they didn't match, then return false. And can you word this another way? Sure thing. You could delete equal equal false, and you could just put an exclamation mark, a not at the beginning of it. But I'm going to leave it like that. Hopefully that's easy enough to type in. Okay, we have a dot equals method. Now our Chevy and our Ford should say that they're the same because they're both red and they both have 4 wheels. So I come back here. I have a Chevy that's red with 4 wheels. I have a Ford that's red with 4 wheels. And so when we compare those two things, we're not going to use equal equal anymore. Instead, we're going to use dot equals. The same is equal to Chevy dot equals the Ford. Then let's print out the result of that. System.out.println Chevy dot equals parentheses Ford. question mark plus the same. Let's run this and see what we get. If we look at it, sure, Chevy and car 2 are pointing to the same object. So when we used equal, it returned true. Chevy equal Ford? No, because they're not pointing to the same object. No matter what the member values were, that would never return true. Does Chevy dot equals Ford? Yes, they do equal because all the member variables are set the same, red and Ford wheels. What if we change it? What if the Ford has 6 wheels rather than 4? Let's just prove that they will no longer be true. So I'm going to change Ford's set wheels to 6. Save that. Run it again. And now dot equals returns false because the Ford had 6 wheels and the Chevy had 4. So whenever you need to compare 2 objects, you have to use dot equals rather than equal. That's true for strings. It's true for anything else. And if it's an object that you create, I mean that you are writing the source code for, if it's for a class that you're creating, you have to provide your own dot equals. And what should the dot equals method do? It should check the members that are important and compare them to each other. And if any of those members that are important are different, it needs to return false. I hope that makes sense. Let's look to see what's next on our agenda. Passing references as arguments. Java is a pass by copy, not a pass by value language. So you should already know this, but we're going to play with this a little bit. I'm going to come up above main and I'm going to add a couple of methods. Public, static, void, change me 1. And it's going to take a string. No, I don't want it to take a string. I want it to take a car. And what it's going to do is it's going to set the number of wheels to that car equal to 10. Silly, but whatever. Okay, so C dot set wheels to 10. Great. This is actually going to work. You can change the members of an object that's passed in. This parameter right here is actually a copy of the reference. So it's actually just containing the same address. Since C, it's like if you're a C++ programmer, it's getting the pointer to it. So it can change any member value of this reference here. But it cannot change the reference itself. Now I am going to write one that does a string. Public, static, void, change string. And it's going to accept a string as a. So string is equal to goodbye, for whatever reason we want to say that. Let's first prove that that is not going to work. Let's create a string. I'm just going to call it message. MSG is equal to hello. Then I'm going to call change S on message. And if you didn't know that it was being passed as the address, you might think that that would work. But it's not going to. If we print that out, it's still going to say hello. So let's print out our message. It'll say hello rather than goodbye. Let's prove that. Hello. The reason why is that we cannot reassign S. Or we can reassign S, but it's just a copy of what was passed in. So message does not get changed. Message is a reference to another object. It's an address. And so if we change the address of this parameter, this variable still points to the old address. So it still says hello. Alright, so we had change me 1 car. this is actually going to work. It will change the value of the car's wheels to 10. Let's prove that. I'm going to add one more line of code, a couple more lines of code. We're going to make a new car. I'm not creative, so I'm just going to call it cnew is equal to new car. His wheels are going to be set to 4. So cnew dot set wheels equal to 4. And then we're going to call change me 1 with cnew. And then we're going to print out the number of wheels. So system.out.println cnew wheels equals plus cnew.get wheels. Right? Okay. And when it runs, it's actually going to print 10 because that's what change me does. Change me changes the value of that member to 10, but it doesn't reassign C. It doesn't create a new object. That's actually what this is doing. So let's give it a shot. And when it runs, it'll show that's the cnews wheels member is, well, I didn't run it, I only built it. What do you know? 10. So that did work. But we cannot reassign this variable to a new one and actually have that change take effect down here. So we're going to rewrite change me. Usually I add a new method called change me too, but I want to keep everything on one screen. So that we're not just changing car C's method, but we're going to create a new car first. Car is C is equal to new car. This new car has 10 wheels. So when we print out cnews wheels, is it going to print out that it has 4 wheels, or is it going to print out that it has 10 wheels? cnew is still going to have 4 wheels. Why? This creates a new object. That new object's member is 10. However, since C is just a pointer to the original address, before we change it, it does not refer to the original object. So we can't change it by that. Java is not a pass-by-reference language. Unlike C++, where you can get that to happen, you just flat out cannot have this return a modified address, a modified reference. Instead, all you can do is change the members of it. You can't pass back an entirely new object that way. So if I run it as predicted, wheels is still equal to 4. This is a brand new object floating out somewhere in memory. It's certainly not the same as this one. And this call to cnew did not reassign this reference to a different address. I hope that's clear. Read chapter 7 carefully. Hopefully it will make sense. Alright, talking about overriding members. Excuse me, overloading members. Is that what we need to cover? Let's go look at the file again. Overloaded methods and overloaded constructors. You can create 2 different methods that have the same name but different parameters. And I'll give you an example of that. I'm going to scroll all of those change me ones and change me whatevers off the screen. I don't care about them anymore. Okay, I'm going to add a new method. I want this one just to be called triple. All it does is take an integer passed into it and triples it. Actually, why don't we just make it a double? So, public static double, nope, call it triple, and it takes a double as its parameter. What does it do? It returns 3 times D. And I forgot to put the return type. public, I said it, but I didn't type it. Public static double. You know what? I'm not liking the fact that it says double triple. That sounds kind of funny, but just go with it. We can see what it does. It returns 3 times D. So if I want to, I could print out system.out.println triple the value of 10. Right? I'm passing a 10 in there. Going to multiply that by 3 and return it. Let's prove that that works. Check my output. Indeed, triple the value of 10 is indeed 30. But what if we wanted to pass in another data type? This is not going to work. System.out.println triple the value of a string. Right? That's not going to work. Why? Because a string is just flat out not compatible with the double. That's why it's underlining here. And that means we can go and check the error message. It says incompatible types. A string cannot be converted to a double. Now we do know how to convert doubles to strings, but we have to do it ourselves. We have to parse it. But we want this code, we don't want to write more, we don't want to have to use different language. We don't want to have to write, triple a double and then triple a string. We don't want methods with different names. We want them to have the same name. So let's go for that. Public static double triple. But this one takes a string. What do we have to do to get this to work? Well, for one thing, we have to spell double correctly. I correct that. We have to create a double from that string. So we're just going to parse it. Doubles D is equal to capital D double, because we're going to use the wrapper class, dot parse double, parentheses S. Now we can return 3 times D. So we convert that string to a numeric value and then multiply by 3 and return it. Now both of these work. We can pass it either a double or we can pass it a string. Sorry, again, I just built it rather than run it. Here we are. Here's the 2 separate calls. Notice that they have the same syntax, the same name. We run it. Let's go check the results. And 3 times the double's value was 30. 3 times the string's value when converted to a double was 30. Alright, so do we have to write a separate version for doubles and ints? No, because ints are cleanly promoted to doubles with no problem whatsoever. Totally fine. So you can just make a function that accepts, a method that accepts a double as its argument, that has a double parameter, and it will accept ints just fine. It will accept longs just fine. It will accept floats just fine. So that's why most of the math classes, most of the methods in the math class accept a double, because that means it can also accept an int or a long or a float. Alright, that's the idea of overloading. We have 2 methods that have the same name but different parameters. Two methods with the same name and different parameters, types. Also, you could overload in a different way. You could make a method that has just 1 parameter, and then the next version of it has 2 parameters, and the next one of them has 3 parameters. You could do that. I'm not going to show that, but you could. I think I showed something like that in one of the other lectures. Maybe I'm misremembering. So for example, you could write an add function that just took 2, and then you could write another add function that just took 3 parameters, and another one that took 4 values to add all together. Those would all be overloads of the same method name. The one thing you can't do is have 2 methods that have the same name, the same parameter type, but different return values, because how would it know which one you expected? Which method gets invoked is based on the argument that is passed in, the type of that argument. You can use constructors the same way. You could write a constructor that accepts a string, and then another one that accepts 2 strings, and then another one that accepts a double, for whatever reason. I'm going to illustrate those for car, but I'm not going to test them out. I'm just going to let you trust that they work. So I'm going to go back to car and add a couple of constructors for it. We already have a default constructor, but once we add a custom constructor, a parameterized constructor, that default constructor no longer works. So I'm going to make a new default constructor. A constructor has no return type. A constructor is a method that has no return type and the same name as the class itself. This one's not going to take any parameters, so that's all I need to do. I'm adding that so that this doesn't break my code when I add the new constructors. Okay, now I'm going to make a method, a constructor that accepts a color. And what does this one do? This .color gets set to the color that gets passed in. I think I will demonstrate these once we type them in. Why not? And then one more constructor that accepts both the type of the string, both the color, and the number of wheels. So this .color is equal to color, and this .wheels is equal to the number of wheels passed in. So we have 3 different ways of creating cars. Let you take a look at them for a moment. 3 overloaded constructors. The first one takes no parameters at all. The second one takes 1 parameter, which is a string. The next one takes 2 parameters, a string and an int. So let's create 3 different cars with all 3 different methods. I'm going to go back to the car class. Car, whatever. What am I going to call this? I'm going to call it Fred is equal to new car with no parameters. So it's just going to have the default values, which are 0 wheels, and the color of it is null. Then we're going to create a new car. Along with Fred, we have Barney. Barney is a new car, but it's a silver car. And then one last. However, the number of wheels for Barney is still going to be set to 0 because that's just a default value that's defined, not even defined in the car class. All of the members of a class default to being set to 0 unless they're initialized or set to another value, or they're set to false or null depending on the type. Alright, and then last one. Wilma is a new car. Wilma is gold with 4 wheels. So you see how this works? The same syntax. Well, I got an error because I passed in 4 as a string rather than as an integer, which is what it really needs to be. There we go. So we have 3 different objects. Their values are set differently. That's an example of overloading constructors. So you know what overloads are. Now you know what overloading constructors are. And again, I bet that was a bit of a review. I felt like talking at considerable length, though, about references and reference equality and creating the dot equals method, because that is an extraordinarily important point, which I'm not sure the beginning Java emphasizes enough. All right. Go ahead and upload your car class and your class with your main method, and you're good to go. I'll scroll from top to bottom just so you get a chance to look at it. Of course, your package does not have to be the same as mine. Here's the class. Here's some methods. Scroll down. Here's some more methods. Scroll down. Here's the main method. Here's some of it. Scroll down. Here's some more of the main method. Scroll down. Here's still yet more of the main method. Scroll down, and then we created our 3 cars. It's the end of the main method. Going back to the car class itself, whatever your package declaration is fine. You don't need that one. It had 2 members, wheels and color. These are instance members because they're not declared static. Then we had the 3 constructors, like that. Then we had our dot equals method, so that we could compare 2 objects and make sure they had equal member values. Then we had some getters and setters, our mutators and our accessors. All right, talk to you next time.